Thomas, and today we're going to start an experiment to see how a beacon that uses a power no less than this light bulb, how far that beacon signal can get. I'm a licensed extra class amateur radio operator, so I can transmit on a 30 meter band, yes, on a 30 meter band with our beacon to see how far it gets. To make it more interesting, I'm going to build the radio myself. I'm very excited and I'm ready to get started, so roll the footage. So, I'm going to do a little experiment here, and we're going to measure the power that's flowing through this here light bulb, and then compare it to the power that we're going to be putting through our radio beacon. So first, we need to measure the amps to get the first part of our formula. We do this with this multimeter. We have it set as at a maximum of 10 amps because we know that this is never going to exceed 10 amps. And we make sure that this red plug is plugged in right here. So now we put the battery upright like this because we had some technical difficulties doing it this way. So we put it up like this, and we do here. And since the light bulb lights up, and we put it here, you see on the multimeter, comes out as 0.19 amps. So for amps, we can write down 0.2. Okay, so now that we've done that, we need to set the maximum to 20 volts because we know that this is never going to exceed 20 volts. Even if this light bulb doesn't light up, I can still get a reading on the multimeter. So again, we put it upright and put our thing here, and it comes out to roughly 4.75 volts. So we can write that down. 4.75 volts. And now, to get our power, or watts, we need to multiply 4.75 times 0.2. So let me do that right now. So it comes out as 0.95 watts. That's not that much power compared to our radio. We have an output of 100 watts in our radio, so that's less than a 100th of what we put out on our radio. But on our beacon, we're only going to be transmitting out 1/4 of a watt. So more power goes into this light bulb than is needed to power our beacon, which is a good sign. So we can just use 3 batteries like these for our beacon. Hello. Today I'm ready to start working on my radio beacon. This is very exciting because this is the part where I get to build the actual part and start getting into the interactive stuff. Today, I'm going to be talking about the simplest part of the radio, which we're going to build first, called the low-pass filter. A low-pass filter is pretty much an electromagnet, which is running electricity in wires, in coils around a metal core. Some metal cores switch between magnetism and no magnetism faster and slower than others, and the one we're looking for the low-pass filter is one that can magnetize fast enough to let 10 megahertz pass through, but nothing higher. And the way these work is the metal kind of magnetizes and demagnetizes at 10 or less megahertz, and when it does that, it allows radio signals to pass through it. and when it allows radio signals to pass through it, you can get the signal on the radio and be able to, listen to it. And it doesn't allow anything higher than that because it can't magnetize fast enough, and it will always scale down back to 10 megahertz, or the selected frequency when you calculate the number of coils and the type of metal core. So the function of a low-pass filter is to let a set frequency in and any frequency lower than it, but nothing higher. And that's what we're going to be building soon. Okay, so what you're looking at here are the parts that I'm going to be using to make my low-pass filter. These aren't lifesavers, they're actually little toroids, which I will wrap this conductor around about 20 times to create our magnetizing material. As you can see, this has a lot of precise measurements. I'm actually kind of nervous about this to wind it around here, but I'm pretty sure I'll get it. So I'm going to be waiting till tomorrow to do this so I have some nice lighting. When we're all finished winding the toroids and doing the other parts, we'll put it onto this breadboard and we will have completed our low pass filter. So again, I'll be waiting for tomorrow because there's poor lighting right now, and tomorrow it'll be nice daylight and I'll be able to do these. So see you then. So I've started winding the toroids, and this is a little bit tricky because the parts are very small, but with a little bit of patience I'll be able to do it. Every time I put the wire through the hole, that counts as one turn. So far, I've done 2. I have to space them out. I have to space them far out enough so that they don't touch. And here we go already. I'm having a little bit of difficulty. Okay, so here we go. I did all 21 turns. It was a little bit of a challenge and very time consuming because, well, mostly because I'm left-handed, but with patience and persistence, I got it done. So, the wire I used to wind the toroids actually has enamel on it, which means that when the 2 wires touch, they won't short. But that's a problem for when we're soldering, because when we're soldering, electricity has to flow through. So, before I solder, I have to scrape and clean the enameled wires very carefully. While I was winding my toroids, I noticed something very interesting. I noticed that on my mouse, we have those little bumpy things there. Well, after a little bit of searching, I found that they were actually low-pass and high-pass filters. Exactly what I'm building. They serve the exact same purpose. These allow a certain frequency to go through the wire and nothing else. Not any frequency higher and not any frequency lower. Pretty cool, right? So we're ready to start soldering. I've got my goggles on, and as you can see, the parts are very tiny, so I'm going to need a lot of very tedious work to be able to do this. So we're just going to go ahead and get started. And also, after we finish the low-pass filter, we won't be able to test it, so after we do the entire radio is the only time we'll be able to test it. So I'm kind of nervous about this, actually. But anyway, we're just gonna head on.
Georgia. If y'all have not seen that place, go look at it. Tell them I sent you. And it's terrible, dude. Birmingham Airport is kind of out in the woods. Well, ain't no kind to do it. I'm out in the woods.
I finished soldering the board, but I faced a couple challenges while doing it. Number one is that it's really small, so it took me a couple minutes just to get one of the things down. Number two is I'm not that great at soldering, so I had to constantly unsolder it and resolder. But the greatest challenge is that I'm left-handed, so I was fidgeting a lot while I was trying to solder it. But I really hope that I got it right, but we'll see when we finish the radio. So I'm going to start my receiver next. So I talked about making our beacon, but now I want to take this time to talk about the modes that we'll be using. It's mainly between two modes, CW or Morse code, and Whisper. Morse code is very efficient at sending out signals because it packs its signal into a very narrow bandwidth. But the worldwide network can only report the stronger signals, meaning that the weaker ones heard don't really pass through. While Whisper, on the other hand, is especially made for beacons and weak signal transmitting, and it even has built-in error correction, which means that it transmits multiple times so that no errors pass through. And the worldwide network is able to receive all types of Whisper signals, weak or strong. So I'm guessing that Whisper is going to be the best method for us to transmit through our beacon, but of course we're going to test it just in case. My beacon is going to use less than 1 watt of power, so I've set my radio to 1 watt of power, and I've set up my computer to transmit Whisper, and I'm going to see if any station in the world is going to transmit back to me that say that they heard us. I just finished transmitting a 1 watt signal through Whisper, and as you can see, a lot of stations heard my call, and that proves that even 1 watt of power can get my signal all around the world. And when we finish building it, I'm going to test the beacon to see if the same thing will happen. As mentioned before, Morse code is a very efficient mode, and I ran some journal CQs on it, and I was detected by several listening stations, but not many, and I was running 25 watts, which is about 100 times higher power than the beacon. And I know that CW can travel the world easily, but listening stations usually filter out weaker signals. So, as you can see, Whisper was definitely the better choice, and so I picked Whisper to be transmitted from my beacon. So these are the parts that we have for our receiver and transmitter. Here we have our capacitors, our resistors, our potentiometers, which are pretty much like volume knobs on the radio. We have our breadboard here, which is what we're going to put everything here. And we have a toroid, which I'll need to wind again. Well, and we have our microcontroller or microcomputer. The interesting thing about this is that they're the same thing in every single Arduino kit, and we can plug them in right into this cloner here and clone it onto one of these using a computer. And I'll probably use that for a future project, but not for this one. So my next step is to get my soldering iron ready and solder all this onto the breadboard and get our receiver and transmitter done. Okay, so a couple hours more of soldering and I should be done. Got it. All right. Got it. Synthesizer. It's essentially a clock, and when it's connected to the radio can make the clock into something that transmits electromagnetic waves at the frequency the clock is going. Once you get the wave like this, there are three properties of it. The amplitude, which is how far up it goes, the wavelength, the distance between the dips, and frequency, how many dips it makes. And there are ways you can make electromagnetic waves in such a way. The first is amplitude modulation. That's where you modulate the amplitude of the wave. So to carry information, you modulate the amplitude, and it varies in heights. And frequency modulation is when you modulate the frequency, how many times it polarizes. But whisper modulation is very complex, but it follows the same principles. This is the GPS unit. I had to take a break while soldering because I'm having a little trouble with the Zener diode. What it does is it's essentially a regular diode, but it allows some electricity to come back. A normal diode just lets it go in one direction, but a Zener diode lets it go in two directions. And the problem with this is that it has a directionality. I need to find the stripe to be able to solder it and put it in the right direction, but I can't find it, which is why I had to take a break. This is a transistor. The transistor is pretty much another word for an amplifier. The more you have, the more power you put out. Since I'm only using one small transistor, the circuit I'm using is going to have very little power. This is where my low-pass filter goes, so I'm going to get around to soldering it and make sure it fits in place. I'm going to mount this LCD screen. It's a little tricky because I don't have that much experience with screwing things in. But we're going to need this so we can program a couple options into the radio. So here we have my partially assembled radio. We have our LCD on the bottom, our main transmitter up here, our frequency synthesizer right here, and our low-pass filter. What's missing from the picture is a power supply, an antenna, and GPS systems, so I need to get to work. Is almost finished. We have everything, and it's about finished to the point where I can pretty much test it. So, we have our jumper cables, which connect to this battery holder. We have 4 batteries there. They add up to about 6 volts, even though the circuit needs about 5 volts, but we have 6 for testing purposes. And now we're going to put on the cover. There we go. And turn it around. And here we have our off and on switch. So I'm going to turn it on. Oh, and the screen lights up. So it does work. Good. And the reason it has nothing on it is because the contrast might be a little too high. And there's a little potentiometer right here that I can turn to lower the contrast. There we go. So now it's in diagnostic mode. I will soon program my call sign and everything into it so that it will be able to transmit and get around the world. So this is my contraption. It's powered by 4 batteries, in this case right here. And we've hooked it up so that it transmits a Morse code signal through the beacon. And right now we're listening to it from our home radio, and we're getting a pretty nice signal out of it. If you can't read Morse code, what it's saying is test from N1SPY, which is my radio call sign. So that's the great news. And our project is almost complete. All we need is a GPS. So these are the final results of my project. As you can see, the beacon has reached many places around the world, and I'm very happy about that because honestly I didn't expect it to, but I'm very glad that this little contraption here has made it that far, and I'm very happy that my project was a success as well. So I look forward to using this and doing many other projects. Thank you for watching.